Welcome to Family Monday. Let's talk today about some special Lakehouse tables. Lakehouse special tables. They are located inside the Query Insights schema. This is interesting because notebooks don't support the schemas. So if they are located inside the Query Insights schema, this means that we can only access them through the SQL Analytics endpoint. We can't access them through notebooks. Available only on the default dataset. We can't expose these tables in custom datasets. Only the full dataset contains these tables. Exec request history contains a history of the requests on our Lakehouse. Frequently run queries which are very frequent, and long-running queries. At this point, you may already be imagining what you can build with the information on these tables. We have a lot of information on these tables. Let's take a look on them. Here we have a Lakehouse, and I'm starting to make some queries over exec request history. I'm requesting always the top 10, it's an example, but I can request the top 10 by the row count, number of rows that this query returned, by the total elapsed time, or filter by status, which ones were the less failed queries on the Lakehouse. And in this other example, I'm grouping by the hash, by the query hash of the query, counting the executions and making calculations, sum and standard deviation of the total elapsed time, ordered by number of executions. Let's take a look on this. Let's execute. So we are seeing the top 10 queries related to row count, the amount of rows returned by the query. The next one, total elapsed time, related to total elapsed time. And the last failed queries on the Lakehouse, which queries failed the execution. And I can identify the queries, the executions of the same query by the query hash, grouping by the query hash, and getting the top 10 by the query hash. So I grouped the queries and got the top 10 executions according to the query hash and made some specific calculations, like the total elapsed time and the standard deviation time. A standard deviation time will show to me if the query changes a lot or the amount of time it takes to execute or not, if it's always a very similar amount of time. That's interesting to calculate. Let's take a look on another table, the frequently run table. Here I'm getting the top 10 frequently running queries based on the number of the executions. Top 10 based on the total elapsed time. But mind that the total elapsed time needs to be calculated because each row in the frequently run queries is referenced to a query, but not one single execution. This query was executed many times. So we need to calculate the average total elapsed time multiplied by the number of runs to get an approximate total elapsed time and get a result from it. Number of failed runs, how many queries are failing? And how many queries are failing more than having success? So we can get this by using the frequently run queries. Let's take a look on the result of these queries. So this is ordered by the number of executions the query had. This other one by the approximate calculation of the total elapsed time. Queries which are failing. We have 2 frequent queries which are failing. And queries which are failing more than having success. Only one is failing more than its number of success executions. The third table, long-running queries. Again, I can retrieve them by the number of executions. I can calculate the total elapsed time and return them by total elapsed, but now I'm referring by long-running queries. And I can get the difference between the total elapsed of the last one and the average of total elapsed of execution. And the biggest difference means the queries are changing or having problems. So the first one, from long queries, also number of runs, based on a calculation of total elapsed time of these queries, and about a difference calculation between the last run and the average run of the executions. So this one has a considerable difference. The last one took way more time than the average. It may lead to a problem. Besides that, we can even build a dashboard to monitor our Lakehouse. Like this dashboard, for example, where I created one page of the report for each one of the tables: request history, frequently run, and long running, and I'm listing the results of these queries by total rows returned. On the request history, I have query by query, so total rows returned, total time of execution, and I can list the name of the program which is executing these queries, from where these queries are coming, the failed queries and the logins which are executing these queries, and by filtering by one distributed statement, I can check the code of the query. There it is, it's showing me the code of the query based on the selected distributed statement. Similar tables can be built for the frequently runs based on total runs, total elapsed time, and total failures in this example, and also for the long-running queries based on number of executions, total elapsed times, and the difference between the last execution and the average execution. And I can also see the query itself. It's interesting to note that these tables are only available on the default semantic model. In this way, I can't make any changes like relationships or anything like this. So anything like this needs to be done on the Lakehouse, on the model of the Lakehouse. I can build relationships for this special table. In this case, I made a relationship related to the distributed statement ID. I related the distributed statement ID from the frequently run queries and long-running queries to the exec request history. We can also configure how we would like to see some fields. For example, the total elapsed time, for example. We can make configurations of the way we would like to see the fields, like enable the thousand separator. We need to do this on the level of the Lakehouse, because when we build the Power BI report, we are working live to the default semantic model. we can't make any of this configuration. We need to do this on the model of the Lakehouse. Thank you very much for watching. See you next week.